In this video, we will see how to detect wildfires using satellite imagery in Google Earth Engine. The video will be step-by-step guide for beginners. It will be a beginners-friendly video. So let's see how to do that. First, let's see a brief introduction. Why we detect wildfires with satellite image. Detection of wildfire is very important because it has ecological and economical damage. Using satellite imagery has some benefits such as this can be done in large scale and near real-time monitoring can be done. And Google Earth Engine allows free access to satellite data. It uses cloud computing, so we can easily analyze large area. Which satellites could be used for wildfire detection? Sentinel-2 is very good because it is high resolution and it has multispectral options as well. And Landsat could be used, but Sentinel-2 has 10-meter resolution for most of the bands, and Landsat has 30-meter resolution. But another benefit of Landsat is it has long-term historical data, and we could also use MODIS and VIRS for thermal detection. Let's try to understand how satellite detects wildfire. It could be detected by three sensors. One is optical sensors. With optical sensors, we could determine burn scar with normalized difference vegetation index or normalized burn ratio. This type of indexes can help us to determine the burn scars. And thermal sensors can actively determine the fire's hotspots. Smoke plumes can determine the aerosol. Today we will use Sentinel-2 imagery to determine NBR using band 8 and band 12. Band 8 determines the vegetation health, and band 11 and 12 shortwave infrared bands can determine burn scar. To write the code in Google Earth Engine, we need to go to the URL, that is code.earthengine.google.com. Then we have to sign in with a Google account. We need to create a Google Earth Engine account with our Google account. If you do not have one, then you need to create one. If you would like to know how to create a Google Earth Engine account, you can see the video in our channel. Then in the code editor, we can write JavaScript code. Today we will try to detect the wildfire in Ofunato, Japan that has taken place in February 2025. First, we need to define the study area. This is the code for making the study area. First, we made a variable named Ofunato. This is the name of the place where the wildfire has taken place. And the coordinate of this area is this. And we use g.geometry.point function. Then we will make another variable named region, which will be 10 kilometers around this point. So our study area will be a circle around the point. This is time for loading our Sentinel-2 image in the code editor. For the analysis, we will not use single date image. We will use image for 1 or 2 months. From all those images, we will use median reducer to make a single image. Before doing that, we need to date. One is before fire and another one is after fire. In Ofunato, the wildfire has taken place between February 26 and March 9. So we set a before fire date February 20 and after fire date is March 9th. First, we will make an image collection named before collection, and we will use e.imageCollection function. and the image collection will be European Space Agency Copernicus Sentinel-2 surface reflectance harmonized dataset, and we will filter the images with our region geometry. So it will only focus on our Ofunato area and region geometry that we have made from the point around 10 km radius. Now with filter date we need to insert two date, from and to. So this is the from date and this is to date. To date will be this date. So to 20th February of 2025, and from date will be the before date dot advance minus 2 month. That means 2 months ago of this date. So we will make a image collection previous 2 months of 20th February. That means around 20th December 2024 to 20th February 2025. And we will make another after collection image collection, likewise this one. Here we will use this date as the from date, and to date will be 2 months from the after fire date. And then we need to cloud masking of this Sentinel-2 imagery. This is the algorithm for cloud masking of Sentinel-2 image. Sentinel-2 has a band called QA60, that is quality assurance band. First we make a variable called QA and select the quality assurance, and then make two variables for bit mask. First one is cloud bit mask and second one is cirrus bit mask. For cloud bit mask we use bitwise operator, and for cirrus bit mask we also use bitwise operator. For cloud bit mask it is 10 shift, and for cirrus bit mask it is 11 shift. Now we have cloud bit mask and cirrus bit mask. Now we need to make the mask from this bit mask. For that we use bitwise AND operator. Then we will use image.updateMask function to mask out our clouds and cirrus, and finally divide by 10,000 to make the integer values between 0 and 1. This is the algorithm for masking the clouds and cirrus. Now we need to apply this cloud mask and create median composite. So let's make a variable called before image. First we will take our before collection image collection and use the map function and pass it to this function. So what map function does is it takes first image from this image collection and send it to this function. Then all this cloud and cirrus bit mask cloud masking operation is done. Then it returns the image with masking and dividing by 10,000, and then second image, then third image, and it's something like a loop. Takes one input at a time and do the processing, and then next. Now we have the cloud masked image. We will use the median reducer to make all those images a single image. Now the image will be bigger image in size, but we do not need the whole image, we only need our region, so we will clip it to our region. In the same way we will make the after image, and cloud masking is done by map function, then median, and also the clip. Now this is time for visualize our true color image. Sentinel-2 has 13 spectral bands, but for true color image we need to define the red, green and blue. B4 is red, B3 is green and B2 is blue band. Since we have divided the values by 10,000, so it will be between 0 and 1. For minimum value we usually use 0, and for maximum value we use 0.3, but we can change that later as per demand. Then we need to center the map to our object, that is region, and we inserted 12 as the zoom level. Then let's add those layers to our map. So let's do it using add layer function, map.add layer. Then we use the before image and visualization parameters that we have written here. We pass it to the second argument, and then third one is the name. We can write anything. We have written before fire, and for the after fire we have written after fire. The name is the layer name that we can easily identify. Then we will see those two images, before image and after image. Before fire image should be green healthy vegetation, and after fire image should look like dark brown or black burn scars like this. At this time, let's go to Google Earth Engine and let's run the code and see what happens. We have opened our Google Earth Engine code editor and have written all those codes. So this is for our study area, and these are two dates, before date and after date, and image collection, and then cloud masking algorithm and cloud masking application, and making the median and clipping the images, and then display true color image. Let's run the code. We can see that our map is zoomed to the region of Ofunato. It is being loaded. Take some time. Both the layers have already been loaded. Let's zoom out and check. We can see that the image is little bit dark. We can change the visualization from here. Click on settings and let's make the range custom stretch to sigma and apply. You can see that our visualization has been little bit improved, and the darker images have been made sort of lighter and brighter. We can import this visualization so that we do not have to do it again and again. Let's click on import and close. You can see that image param has been imported. Now let's copy this and paste in our visualization parameters. And also with this. Now let's run again and see. The visualization is much better than the previous one. We have successfully made our median image and add those layers to our map. Now this is time for computation of burn index, that is NBR index. What does it mean by NBR? NBR means Normalized Burn Ratio, and it is calculated using near-infrared and short-wave infrared two-band of Sentinel imagery. Near-infrared minus short-wave infrared divided by near-infrared plus short-wave infrared. And the interpretation of the NBR value will be high in NBR value means healthy vegetation and low NBR value means burned areas. This is the code for NBR calculation. Google Earth Engine has a default normalized difference function to calculate any normalized difference. We need to pass only two bands and it will automatically calculate the normalized difference of those bands. So we made a function called add NBR. It takes image as input, and then made a variable named NBR. This variable takes the image, and from those image it will take band 8 and band 12 and make the normalized difference and rename this band as NBR. Then return the image with adding the NBR band with that image. Now we pass the before image to this function, and we will get the before NBR image and then after image, and then we will get the image called after NBR, and we put it in a variable. Now we have two images with one band called NBR that we already renamed as NBR. Now we will calculate the difference of those NBR bands of two images before and after. For that, first we take the before image. Since this image not only contains the NBR band, it also contains the other bands from the Sentinel image. So we need to select the band as NBR and then subtract the after image where we also select the NBR band. So before fire NBR will be subtracted by the after fire NBR. So we will get the difference between two NBR. Now is the time for display of the burn severity. First we made a severity palette. There are four colors: blue, green, yellow and red. Then we will add the difference NBR layer as a map layer. So we add this image as a layer, and then minimum value we wrote -1 and maximum value 1. Then we pass the palette that we have created now here and wrote the name of the band. You can write anything here. So when we will run this code, we will get one image like this. And how to interpret this image? The interpretation should be: red areas will be severe burned areas, moderately burned areas will be yellow-like, and the green and other areas are unburned. Now let's go to Google Earth Engine and run the code. In Google Earth Engine we have written the codes. So first calculate NBR and then pass those images to this function, and then calculate the difference of those NBR bands, and finally visualization of burn severity. Let's run the code. The layers have already been loaded. Let's check. You can see that this is the most damaged area in this wildfire. We can hide a layer using this slider so that we can easily detect the change. You can see that this is the after image, and if we hide this, we will get the before image. The before image has green vegetation color, but after fire this area has completely been burned. So burn severity index image shows that. If we go to the inspector tab and inspect this, you can see that this area will have high NBR value, and if we go to this area, green areas, you can see that the NBR value will be lower. The lower NBR value means it is not damaged. Since this is the difference NBR value, the more the difference is, the more damage has been occurred. So before and after image difference here is minimum. That means this area has not been changed over time. But here the difference is high because this area has already been burned. Now finally, if we want to export our result, we can do that. This export could be helpful if we want to analyze anything in or make the map in QGIS or ArcGIS, or doing some time series monitoring or reporting or research. We need to download this. For downloading, we will use export.image.to drive. It will be downloaded to our drive, and then pass the image, difference image, description, the name of the image. We can pass any name, and then scale is 10 meter resolution for Sentinel-2 image, and in the region parameter we need to pass our region, that means region of interest that we have used, and max pixels we can increase it to 1 in 13. If our image size is bigger, we can use it bigger, so 1 in 13. This is the optional step. Now let's run this code to export our result to our drive, and then we can download that image from our drive. Let's run the code again, and if everything okay, then you will see a notification on the task button, and here you will find one unsubmitted task. Just run this. It will open a dialog box. You can write the coordinate system here if you want, like EPSG 4326 for WGS84, and we can pass a folder name. So the file will be saved in our drive's GEE folder, and this will be the file name. It is okay. And file format we use GeoTIFF. You can change it to TIFF record image if you want. And now you can run this. It will take some time. The file has been successfully downloaded to our Google folder. When it is done, you can see a button called Open in Drive. Click on this and it will take you to your Google Drive. You can see our image has been downloaded to our Google Drive. Let's download this to our computer. We have downloaded the image in our computer. Now let's open this in QGIS. We can simply drag and drop in QGIS. Since this is a single band image, it will not show in color. But if we want to show the color like in Google Earth Engine, we need to do some sort of symbology. For that, let's go to the properties and symbology. Then you need to go to the single band pseudo color. Here we will find some options. First, let's go to equal interval and then make the class 4. Okay, go to properties again to change the colors. First, we will use the blue color, blue, and second one green, then third one yellow, and fourth one is red. And apply. Okay. Now we have excellent color combination, we can easily detect the burn area. Thanks for watching.